Okay, numbers 7 through 18 represent the rationals unit. And if you remember, rationals is just another word for fraction. Rational does mean fraction, a number that can be represented as a fraction. So here, more specifically, these rationals almost always have variables in the denominator, which we'll either have to simplify or solve equations. Number 7, you have to perform the operations. As you can see, multiplication here, division here, and then we need to simplify. So there's a lot going on here, and that's why I've sort of helped you along with this one. So factor everything possible. If you remember all your factoring methods, there's factoring by grouping, there's greatest common factor, GCF extraction, there's factoring trinomials, and finally there's factoring difference of squares. So let's take a look. This one has pretty much everything in it. First of all, when we see this numerator up here, this has 4 terms in it, we're going to factor by grouping. So we group the first 2 terms, group the second 2 terms, and we can factor out a greatest common factor from each pair. So here we have x squared is factored out, we're left with x minus 3. We factor out a 6 over here, we're left with x minus 3. Because x minus 3 and x minus 3 match up, we know that we have done factoring by grouping correctly. So our last step for factoring by grouping is to group the x squared and the plus 6 together to end up with this binomial times x minus 3, this binomial. Now the denominator, x squared minus 4x, we can factor out an x, which gives us x parentheses x minus 4. Okay, so let's concentrate on the middle term here. 2x minus 4, we can factor out a 2. We end up with 2 times parentheses x minus 2. The denominator, if you look carefully, you can see that the GCF is x cubed, and we factor out x cubed, we end up with x cubed times x minus 3. Divided by, now this is our trinomial, which we can factor out. We break it down to x plus 4 times x minus 2. And notice the denominator is 16 minus x squared. This is a difference of squares, but before we do that, we want to factor out a -1 so we can reverse the order. If you notice, everything else starts with the x's or x to some power. So over here we want to make this x squared minus 16. So in order to do this, we're going to use the -1 method. Factor out the -1, and now we have -1 times x plus 4, x minus 4. Okay, I will leave the fun part to you. Make sure that you do your keep, change, flip, change this to multiplication, flip this entire fraction, and then cancel, cancel, cancel. There's a lot to cancel away. For example, the x minus 2 will cancel with x minus 2. The x minus 3 will cancel with x minus 3. You get the point. Okay, number 8. Express in simplest form this big complex fraction. So you need to remember, you want to rewrite this with the division sign. Okay? So that's what we've done here. I've rewritten, here's the numerator, divided by the denominator. Okay? Once again, like the previous problem, 4 minus x squared, we want this to be x squared minus 4. So we're going to factor out a -1 to switch the order, then factor the difference of squares. I'll let you do that. And the denominator, you want to factor out the trinomial. And again, 2x minus 4 here can be factored. You're going to factor out a GCF of 2. So once you have everything factored, again, you're going to simplify. Okay, notice with number 9, we are adding rationals. We're adding this fraction with this fraction. And whenever you add fractions, you need a common denominator. So here we're so close to having a common denominator. We have 2y minus 6 here and 6 minus 2y on the right. They are not common. These are actually called opposite they're opposites, because this is one version and this is a negative version of this version. So in order to make it the same, to get that common denominator, you need to use the -1 method to factor it out. So as you can see, we factor out a -1, which gives us 2y minus 6. Now this -1, since it's now a part of this whole fraction, it basically changes the entire fraction from positive to negative. So as you can see here, it's positive, and this -1 is going to multiply this entire fraction, thus making it -9 over 2y minus 6. And now that we're over here, we can rewrite this whole fraction, or this problem, under, or rather over, the same denominator of 2y minus 6. So let me just give you that last step. 3y minus 9 all over 2y minus 6. And now we're sharing the denominator. So for the rest of this problem, you want to factor out a GCF in the numerator, factor out a GCF in the denominator, and simplify. All right, number 10, we're looking at rational equations. It's an equation because we have an equal sign. So first thing you must do is to multiply each term by the least common denominator, the LCD, which we can quickly identify as x minus 3, because we have x minus 3 here, x minus 3 here. And what's the denominator of 2? It's just 1, right? So we'll multiply everything by the LCD. X minus 3 times this, x minus 3 times this, x minus 3 times this. The convenient thing is that these x minus 3's cancel out, these x minus 3's cancel out, and the 2 is going to have to multiply x minus 3 by distributing. That gives us 2x, and 2 times -3 is -6. 4x equals 2x minus 6 plus 12 is much easier to solve than the original equation. Here is another rational equation where the LCD is not as obvious. So here we have x plus 3, we have 3 minus x, we have x squared minus 9. We're going to go ahead and use the -1 method to reverse this to make it x minus 3. So as you can see, we factored out the -1, and the -1 and the negative will make positive. On the right side, we went ahead and factored the difference of squares to get x plus 3, x minus 3. So now the LCD is x plus 3, x minus 3, right? It's the least common multiple. So we want to multiply every term, this first one, this second one, and this third one, by x plus 3, x minus 3. Okay, so I paused the video and I actually wrote in x plus 3, x minus 3 times each one of these terms, and now we can go through, we can cancel. X plus 3 cancels with x plus 3, x minus 3 cancels with x minus 3, and both of these cancel out, leaving x minus 3 plus, let's distribute this, we have 2x plus 6 equals 4. And I will let you finish this one up. Okay, this rational equation is a little simpler. As you can see, we only have one fraction, 13 over x. So the LCD is basically x. We're going to multiply every term by x. So we're going to end up with these x's canceling. We have 13 equals 10x minus x squared, right? That's the first method. The second method would be to cross multiply. So you can rewrite this equation with a 1 as a denominator for 10 minus x. And then we can go through and we can cross multiply. Okay, there we go. So 13 times 1 is 13, and then x times 10 minus x will need to be distributed 10x minus x squared, which gives you the exact same thing as method 1. Okay, number 13, we need to simplify this complex fraction, and what you have to do is find the LCD for both the numerator and the denominator. So we have two fractions in the numerator. The LCD is 4x. Whenever you're not sure, you can simply multiply 4 times x and multiply the denominators. You will always end up with a common multiple. It may not be the least common multiple, but it will work. So we're going to multiply by x in the denominator and the numerator here, multiply by 4 on the top and the bottom here. We end up with x squared minus 4. Both of the denominators are 4x. Now down here in the denominator, we're going to multiply by 2 and multiply by x over here. So as you can see, our LCD is also 4x. So we end up with 2 over 4x plus x over 4x. Okay? What do I mean by combined fractions? Well, what I mean is rewrite these so you're sharing a denominator. So it's x squared minus 4 all over 4x. 2 plus x all over 4x. And then you want to do your keep, change, flip, and then simplify, which means cancel any common factors out. Number 14 is pretty much the same as number 13. You want to find the common denominator here. We know that the common denominator is x, so we'll multiply times x here times x here. We see the least common denominator is x squared, so we'll need to multiply this by x squared, this by x squared, and we'll need to multiply this term here by x and by x to give us x squared. Okay, so be very careful with this. Keep, change, flip, factor if possible, and simplify. Number 15, here we have if p varies inversely as q and p equals 10 when q equals 3 halves, what is the value of p when q equals 3 over 5? Now, inverse variation is different from direct variation. Direct variation is quotient equals quotient. Inverse variation is product equals product. So we take our variables, p and q, we say p times q equals p times q. Because we have a p here, a q here, a q here. What is p? Well, we just set it up like that. So we say pq equals pq. 10 goes with 3 halves, so we have 10 times 3 halves equals 3/5 times p. 5/3 times 15 equals, so we multiply both sides by 5/3. This gives us 25 equals p. There's your answer. Okay? Wanted to do one of these for you. Number 16, same thing. We have inverse variation, which means product equals product. So here we have p times q equals p times q. Just remember that this time one of the variables is a binomial. Okay, it's an expression, so make sure when you're multiplying, you put it in parentheses. Number 17, more inverse variation. This one I also pretty much did all the way through for you because this one's a little different. It has the inverse proportion. Y is inversely proportional to the square of x. So instead of product equals product, it's instead of x times y equals x times y, it's x squared times y equals x squared times y. Okay, and as you can see, the first two ordered pairs work out beautifully. We have 2 squared times 3 equals 4 squared times 3/4. 4 times 3 is 12, and 16 times 3/4 is 12. So that checks out. So we set it up the same way, except now with this ordered pair, which the y value is unknown, we use the variable d. So we have x squared y equals x squared times y. Plug in our values. I went ahead and chose to use 2, 3 because it's easier to use than this fraction right here. And the result is d equals 1/3. Number 18, also inverse variation because it says inverse proportional. Here I drew the rectangles for you. One of these rectangles, the length is 12, the width is 6. In the other rectangle, the length is 9. What is the width? Well, you're going to set this up the exact same way. Length times width equals length times width. Solve for the unknown, which I've used as x.